Sir, we are live now, sir. Please start.
No, I am not able to see that link. Can you? Acha, from here I can go, right?
Yes, I posted in the chat, sir. You can see.
Okay, great. Yeah. Okay, welcome to today's session. So I didn't get much questions through feedback. So I'm going to explain you or solve the week 1 assignment. So can you please confirm that week 1 deadline is over in the chat? Because that's what I received an email. In the chat, can you put whether week 1 assignment deadline is over or not? Yeah, Roshan, yes. Is week 1 deadline is over? Week 1 and 2 deadline is supposed to be yesterday, day before yesterday. Okay, so we'll discuss those solutions today. And okay, the plot of the current versus time and voltage versus time across an element is given below. The element is. So we have to figure out the element which is given here. Okay, so this is the current, that's the voltage. If you see, if you observe here, this curve on the bottom is a derivative of the top curve. So basically I can express it as di by dt. So some V and I are related to this expression. How? So if I differentiate a constant here, first segment, I get a constant. And again, this is going to have a negative slope. So I got a negative slope. And here it's constant, so it should result into 0. Again, it's a negative slope, so I should have a negative answer. Here is a positive slope, there should be a positive answer here. So V and I are related to this relationship. V is directly proportional to di by dt. So what does it mean? It must be an inductor. For an inductor, voltage across an inductor and current through it are related to this relationship. Because of this, the answer for the first question is inductor. Okay, now let's go to the second question. It's a very easy question. Okay. For the circuit shown below, current through the inductor IL and voltage across capacitor VC at 3 milliseconds we want to find. Okay, so the voltage across the inductor is given. This is a waveform, and we want to find current through the inductor, right? So the current and voltage across the inductor are related to an integral. So I is equal to 1 by L integral V dt. It means I have to basically integrate this curve to get voltage. I have to integrate this voltage to get the current. Okay. So if you observe here, this is 2, this is 2.5. So from 2.5 milliseconds to 3.5 milliseconds, I have one triangle with area positive. Right? I want to integrate till what value? Till 3 milliseconds, correct? 3 milliseconds till this point. Now, if you see, from minus 1 volt, the voltage went to 0. From 0, the voltage went to 1 volt. So it means what I'm going to shade here, right? See, for example, I'm going to share this portion here. And I'm going to share this portion here. So all the LOs are equal, positive and negative area. So that if you sum them up, those two areas, you'll get 0, right? So what I'm left up with is one triangle here, another triangle here, which is a negative, right? So basically, if you see the area of this triangle, if I compute, of base is 1 millisecond, height is -1, plus another 1 milliseconds, it's constant, 1 millisecond minus 1. So it's basically minus 1.5 milli, okay? And divided by inductor 1 milli. So this is the area. I want current through it, which is 1 by L, area under that voltage curve. So if I do this, I get minus 1.5 amps because the inductor value is 1 milli. Okay, so the answer is here. But we want to find the voltage across the cap also, right? So voltage across the cap is I equal to 1 by L integral v dt, and also so this is the curve which is going through it. So voltage across the cap is straightforward. It's 3 volts because there is no change. That's what you're applying. That's what you're going to get. So this is an answer. Straightforward question. So if you have any doubts, you put it in the chat. So we'll come back at the end and we'll see the answers. Okay. Now, let me go to the question 2. For the circuit and the graph shown below, current through the inductor IL at 1 millisecond is, right? Okay. This question is very tricky. I don't know how many of you could answer this question. So the problem here is that the value of inductance itself is a function of the current going through the voltage across it, right? Okay. Now what are we interested in? We are interested in voltage across the inductor. So current through the inductor. So current through the inductor, we are interested. And now the voltage across the inductor is given. So 1 by L integral v dt. This is what the relationship we learned for a current and voltage. So what you have to do for this question is, actually the value of inductance is also a function of time. So you cannot simply use this straight relationship to solve it. So otherwise, other way to look at this. So V equal to L di by dt. This is what the relationship you write for an inductor, constant inductor. But if an inductor which is a function of time, then you cannot write it. You have to write it as V equal to d by dt of L times I. Okay. Now, this is the relationship. Now, where L also is a function of time, and the voltage across it also is a function of time. Now, you cannot separate it this way. So, you can write that V is, the voltage across the inductor is L times di by dt plus I times dl by dt. This is the relationship. Okay. Now, at what time we are interested in it? 1 millisecond. So 1 millisecond means here, right? So here, if you see, the voltage across the inductor at 1 millisecond is 2 volts, right? L is 2 times Vx. That is 2 times 2, that is 4 times di by dt plus the current, I don't know what it is, I, and dl by dt, the slope of this line at 1 millisecond. If you try to find the slope of this line at 1 millisecond, what do you get? You get it as 2 by 1 millisecond, right? So what I'm trying to tell is the current I don't know, and dl by dt I know. Dl by dt is the slope of this line multiplied by 2, because L is 2 times Vx, 2 times Vx. 2 is there. Vx is this guy. This slope is 2 by 1 milli. So basically we got an equation which is 2 is equal to 4 times di by dt plus I times 4 by 1 milli. Now you can use the initial current in the inductor is 0. So you can solve this equation as a function of time and substitute its value at t equal to 1 millisecond. So This mathematics you have to solve it. So you get an exponential or whatever integral term you get, you have to solve it and substitute at 1 millisecond. So you have to solve this integral from 0 to 1 millisecond. You can separate the variables and integrate it. Okay. Now the next question is, for the circuit shown below, Vin is equal to 10 volts, RL equal 3 ohms, R1, R2 equal 4 ohms, and beta 1, beta 2 equal 3 volts. 3. We want to find V out by Vs. Okay. So V out is here and Vs is here. Okay. Now, we have to apply KCL and KVL here. So if you see the current which is entering into the resistor here, 3I1 and 3I2, both are coming here. And I1, I2, and all of them are entering into this resistor. So the V out basically is equal to 3I1 plus 3I2 times RL. This is V out. V out is equal to 3I1 plus 3I2. Plus, sorry, I1 plus I2 times RL. Correct? So V out is equal to this 3I1, 3I2, both are going. I1, I2 are going. So the total RL current is that 4I1 and 4I2 is the current going to the RL. But we are not interested in the relationship between V out and I1 and I2. So we can also say another relationship. Vs is equal to, you can say that Vs is function of I1. So if I write a KVL around this loop, then what do I get? I get Vs is equal to I1 times R1 plus V out. I can also get another relationship. Vs is equal to I2 times R2 plus V out. Correct? So if I add these two terms, what do I get is 2Vs. If I sum these two plus addition is equal to I1 R1 plus I2 R2 plus 2V out. So now the point here is that what I am interested in is I wanted to eliminate. So basically, how many unknowns are there? I1 and I2 are the unknowns, and we want to express the whole relationship as a function of V out and Vs. So what we can do is we can solve equation 1, equation 2, equation 3. So here, if you see in that way, Vs is known. What is not known is V out. So we want to express V out and Vs. Now, how many equations we have? 3 equations we have. One equation is V out equal 3I1 plus 3I2 RL plus I1 plus I2 RL. Other equation is Vs equal to I1 R1 plus V out. Other equation is Vs equal to I2 R2 plus V out. So this is an equation 1. This is an equation 2. This is an equation 3. So now you can use 3 equations and solve V out, I1 and I2. For the graph shown below, average value of the current is, so we want to find the average current in this. So if you see in this curve, we have a DC quantity constant. On top of it, there is a triangular wave running. So I can basically break this waveform into 2 pieces. The first thing is this time, this is the current time. So there is a constant current of 5 amps plus a triangle. So there is a triangle like this, right? So I want to find the area of this. So what I can do, I'm going to find the area of this guy and area of that guy and find. So average value I want to find. Average value means I have to basically what is there from 0 to 3.14, that's keep repeating, right? So basically 1 by 3.14, right, multiplied by area under this curve. So area under this curve is 1 DC, one triangle, both we can add. So this guy is 5 times 3.14. The other one is of base is again 3.14. Height is this going from 5 to 10. So this fellow is 0 to 5. If I add these two curves, I will get the above curve. So that is 5. So whatever it results into answer. So 3.14 cancels. So 7.5 you get. 7.5. Okay. Now let's go to the next question. Now this question is voltage across capacitor at 1 millisecond and 4 milliseconds is respectively. Right? Now the current through the capacitor is given and we are being asked to find the voltage across the cap. Okay, how do I find the voltage across the cap? We have to see it. Now, voltage across capacitor at 1 millisecond, 4 milliseconds, we have to find. Okay, now if you see, there is an I0 current here, there is a 1 milliamp current here. So if you apply KCL on this node, right, then what do you see? You see I0 minus 1 milliamp here. So here it is I0 minus 1 milliamp. Correct? Okay. Now, if I know current through the capacitor, I can find the voltage across it. What is it? V is equal to 1 by C integral IDT. Okay, it is 1 by 1 microfarad integral IDT. So basically, I have to subtract a 1 milliamp from this curve and do the calculation. Other way to do it is, I'll try to find the area under this curve and subtract 1 milliamp from it. Both are same. So basically the I is equal to I0 minus 1 milliamp dt. So what I'm trying to tell is, I can write it as 1 microampere I0 dt minus 1 by 1 microfarad times 1 milli dt. It means simply T. Okay. Now, what is area under? So, which all time points it's asked 1 millisecond. Till 1 millisecond, what is the area under the curve? Which is 1 by 1 micro of base is 1 milli and height is 1 milli minus 1 by 1 micro times time is 1 milli here. So, yeah, there is also one more 1 milli here. 1 milli times 1 milli. So basically, this micro cancels with milli. This becomes 0.5 volts. That becomes 1 volt, which is equal to minus 0.5 volts. That is at 1 millisecond. But if I want to find at 4 milliseconds, interestingly, this is at. So what did I do here? This is at 1 millisecond. Now, if I want to compute this at 4 millisecond, for example, if you find the area under this curve is cancelling, because this is a, if you really observe here, then I have a positive area here and I have a negative area here. Both of them cancel each other, right? Because of this curve, this term, I don't get any term at 4 millisecond. But because of the other one, I'll get. How much is that? Minus 1 volt. So it's basically answer is minus 0.5 volts and minus 1 volt. Okay. I think this is your 11th and 12th class question. Voltage is volts, current in amps, charge in coulombs, power is in watts. So you can basically answer this. Okay, let's try to answer this question. So many times we think that these resistors we have are basically linear elements, but the resistor also can be non-linear. So when sometimes what happens when the resistor is non-linear, we define its resistance as dV by di, the change in voltage, change in current ratio. For this much change in voltage, that much change in current happens. You take the ratio of dV to di, then you can define it as a resistance. Now, the curve for so it's basically a non-linear resistor. So resistor is there. It need not be linear. V equal to IR is only for linear resistor. For non-linear resistor, it can have a characteristics like this. Okay. So basically, dV by d naught is we want to find, right? So what is the relationship? I naught and V are defined through this relationship. Okay. So where are we interested in? We are interested in finding its slope at 1 volt and minus 1 volt. So this curve becomes I naught equal to A times V square, because for V greater than 0, you can simply replace it by V. So d I naught by dV is equal to 2A times V. Okay. So what is A given? Yeah, so if A is constant, we should assume it as A. So it's basically 2A. Now, similarly, if you see, this is, if you see for V less than 0, it becomes A naught is equal to minus A times V square. Now, again, if you differentiate it, you get d I naught by dV as minus 2AV, where V in this case is minus 1 volt. So it becomes again plus 2A. It means this element is always absorbing the power. So since A is not given, the answer is always 2A. So I repeat, the curve, if you see, it's a parabola, and for V greater than 0, it is AV square. For V less than 0, it becomes minus AV square. Now I differentiate it, it gets minus 2AV, V is minus 1 volt. So I get 2A. Okay, this is question 8. Question 9 is this. For the circuit shown below, current to the inductor IL at 1.5 milliseconds is. So we want to find the current at 1.5 milliseconds. Now, if you see here, this waveform here is a sine wave. Okay, this is a sine wave. This segment. How do I solve it? I wanted to find the current through it. As we just learned, V equal to LdA by dt. I is equal to 1 by L integral dt. So 1 by 1 millihenry integration of this whole sine wave, right? So this can be described as mathematically sine omega t. What is omega there? We have to find. So if you see, omega is defined as 2 pi by t. So if it goes from 0 to 1, it means it's going to have period of 2 milliseconds. So omega is 2 pi divided by 2 milliseconds. So the definition of this equation is sine 2 pi by 2 milli times t, right? Okay, so the integration of this we have to find, right? So integration from 0 to 1 millisecond sine 2 cancels, so it is pi by m times t dt plus c. And now we wanted to find at 1.5 milliseconds. Okay, so the interesting fact is when you write a current, you should write minus infinite to t. And already there is a current in the inductor to start with initial current. How much is that? 0.5 milliamps. So we should write it as is equal to 0.5 milliamps plus 1 by 1 milli, 0 to 1 millis plus. Now the area under this curve we have to find because we are interested in 1.5 milli. What is that area? Simply half of base is 0.5 milli. And height is -1. Right? So you solve this integration, sine will become cos pi m by t multiplied by whatever. You can solve it and substitute, right? And you can simplify it, you get the right answer. Yeah. 13 questions. Okay, so we did this question. Let's see the 10th question. For the circuit shown below, current through the inductor IL, resistor R, capacitor IC at 1.5 milliseconds respectively. Okay. Okay, let's try to find out. First, what we want to find the inductor current. So the initial inductor current is 1 milliampere. Now, as just now we saw it, where do we want to find it? We wanted to find it at 1.5 milliseconds. So always when a triangle is given, you see the area here and the area here are equal. So they cancel. So only we have to find area of this triangle. This only results into answer. That yellow cancels. So it means the area of this is half of base is 0.5 milli, height is 1 volt. That is 0.25 milli, the area of this. Why am I doing it? I know that the current to the inductor is 1 by L integral Vt. So L value is given as 1 millihenry. So 1 by 1 millihenry multiplied by 0.25 millihenry. But story did not end here. Actually, the current equation is minus infinite to t out to right. So already there is an inductor current. How much is that current? 1 milliamp. Yes. So you have to do this plus 1 milliamp. So the answer is 1.25 milliamps for the voltage current to the inductor. Okay. Voltage across resistor is very straightforward because V and I are related to resistance value. Okay. So at 1.5 milliseconds, I have -1 volt. There is no memory in the circuit. So -1 milli by, so IR is -1 volt divided by 1K, which is -1 milliamp. Now we want to find the current to the capacitor. Current to the capacitor is simply derivative of this curve. I equal to, for a capacitor, I is equal to C dV by dt. What is the value of C? 1 micro. What is dV by dt? The derivative of this curve is negative here, right? It started from 1, went to -1, that is -2 change. Divided by dt is 1 millisecond, right? So that means the current is -2 milliamps. So the answer is -2 milli here, 1.25 milli there. Oh, sorry. 0.25 milli, 0.25 milli. Oh, L is also milli, that's also milli. I'm sorry, I think this should be written as 1 amp. The dimensions match, units match. Okay, so this is how you have to solve it. For the 11th question, for the circuit shown below, voltage across the terminal VXY is. Okay. So we have to apply a KVL here, which is, so let's call this VXY is plus minus this way, plus minus VXY minus 20 plus, see this loop, if you see, is open. I'm just measuring the current. There is no current in this. I just wanted to know that this loop is not closed. When the loop is not closed, then there cannot exist a current in 1 kilo ohms, right? There is no current in this loop, so there is no voltage across 1K and 5K. So minus VXY minus Vxy minus 20 minus 10 is equal to 0. Because there is no current in the loop, there is no voltage across 1K, 5K. So simply Vxy will become minus 30. The 12th question is, for the circuit shown below, currents in the below mentioned circuit are, we want to find A, B, C. Okay, where is A? A is here, right? If you apply a KCL, 3 amp is entering, 2 amps entering, so you get 5 amps here. What is B? B, if you see, we know already A, which is 5 amps. This guy is 70, so 75 amps. Minus 75 amps will be B, because the current is coming like this, but the current is, actual current is going that way, so B should be minus 75. Okay, B is minus 75. 40 is coming. So basically, the current here is 75 going into the node, in this node. So C should be equal to 75 entering, 40 leaving. So 75 plus 40. Okay, that's current. Okay, I think we have many questions. We'll do 1, 2 more questions. The current Ix in the below mentioned circuit is, okay. So if you see here, now minus 40 amps is entering here, minus 4 amps is entering here, 20 amps is entering Ix. So you can think of all this as one element inside a box. Different currents are coming, different currents are going. So a sum of all the currents entering into this box should be 0, or sum of all the currents leaving this box should be 0. Or sum of all the currents should be equal to sum of all the leaving currents. Okay. Okay. All the currents entering, minus 40 plus 20 minus Ix minus 4 is equal to 0. So Ix is equal to minus 40 plus 16. That's 24 amps. Very simple. Okay. So this question we will do. This similar question we have done last time. So we will again do this question now. As a practice problem, we have done this question. Okay. How do we do this question? What are we interested in? We are interested in finding V11, and we are also interested in finding V21, V22, V12, all the voltages. So let me try to show you how to find V11. So to solve for the V11, we have to know that there is a mutual inductance, there is a self-inductance, right? Okay. First, let's try to solve V11. V11 is the voltage in the first terminal. Okay, so V11 is equal to L1 di by dt plus M times di2 by dt. This is a basic formula. Okay, what is L1? 1 milli. di1 by dt. We are interested at what time? We are interested at 0.5 milliseconds. So here, right? So if you see the slope of this line, that is 1 amp, it's going in 0.5 milliseconds. So it's 1 by 0.5 milli. That is 1 by 1 milli, 1000, 10,000, whatever, 1 by 0.5 milli. Don't worry about it. That is 2 by milli. For now, let's keep it. Cancel this. Easy. 2 by milli. Right? So nothing I did. This is a current going in the primary side. So L times di by dt I have done. Now, along with this, I have to put M times di by dt also. Okay, M is 2 milli. But the trick here is, if the current is entering into the dotted terminal, you will get a plus terminal, plus minus like this. So it means this term will going to add with this term. It's correct. So 2 milli times di2 by dt. If you see di2 by dt at 0.5, it's a negative slope, right, of the same current. So we get minus 2 by milli. So milli cancels. I get minus 1 volt. This is what V11 is. Okay. Now let's see how to find V12. Okay. I want to solve for V12. So similarly, V12 is equal to L1 di1 by dt, sorry, L2 di2 by dt plus m times da1 by dt. See, the sign of this mutual inductance depends upon current entering or leaving dotted terminals. Okay, so for now, here the current is entering dotted, current is entering dotted. So both self-inductance voltage and the mutual inductance induced voltage will add up to each other. Okay, 3 milli times. So we already found di2 by dt at 1 millisecond, which is minus 2 by milli. And what is the mutual inductance? 2 milli. di1 by dt slope also we found it to be 2 by milli. So milli cancels. So minus 6 plus 4, which is minus 2 volts. So this is how we can derive V11 and V12. Okay. Now let's try to figure out V21 and V22 also. Okay. V21 and V22 both. So what is V21? To solve this V21, we need to understand that the current is not entering the dotted terminal. Current is leaving the dotted terminal. Other way to tell is the current entering the dotted terminal here is minus I2. Okay. Now, so to find V21, so V21 is equal to 1 milli times di1 by dt. See, di1 by dt, di2 by dt we already solved. So I'm writing here for you. di1 by dt we solved it to be 2 by m, 2 by milli. di2 by dt we solved it to be minus 2 by milli. Okay, that's it. Let's use them. So V21 is equal to this 1 milli times di1 by dt, which is 2 by m. Now, again, the current entering data terminal is minus I2, right? So basically, let me write it more clearly so that you can get step by step. Okay, I'm interested to solve V21. So V21 is equal to 1 milli times di1 by dt plus 2 millihenry times d by dt of minus I2, because the current entering the dotted terminal, it to get plus minus in the same addition as its self-induced voltage, the current entering terminal we should take, so minus di2 by dt. So basically 1 milli times 2 by milli minus plus 2 milli times di2 by dt is negative sign. So that is plus 2 by m. And then cancel. So total 4 volts. Okay, good. Now, I wanted to find V22 also. So V22 I'm interested. How do I solve V22? Now the V22, if you see, the current is in this direction, right? So that straight away says that the V22 I'm going to get is a negative voltage of what it is, right? V22 plus here minus here, right? Then the voltage current is actually entering this way. So 3 milli times, right? 3 milli times d by dt of minus I2. So plus 4 by m. And the current is entering the dotted terminal. So I get a at dotted terminal plus voltage. So plus 2 milli is a mutual inductance. da1 by dt is found it to be 2 by m. So mm cancels. So 4 3 is 12, 12 plus 4 16, minus 16 volts. Okay, I think we're done with all the questions. So if you have any doubts in this, you can actually ask now. Yeah, so don't worry about number crunching. You can do it at home, but I just gave you idea how to solve these questions. V11 is -2 volts. Yeah, -2 volts. I'm sorry. Correct. You are correct. You are correct, Ritik. You are correct. Okay. So we are done with the assignment 1. If you have any doubts, you can ask now. So what we will do is week 2, we will solve to next week because it's already late. We'll try to solve the week 2 and also week 3. We'll have an extra class if needed next week. We'll solve week 2 and some exercise problems for week 3 also. Yeah, I'll share you this document. Yes. And the classroom I'll share you. Yes. So assignment 3 deadline is August 25th. Let's see whether we can have another session next week starting so that we get more time to solve it, because let me try to do another session next Monday or something. Okay, thank you. If you don't have any further questions, please give some tips for GATE 2022. No, you have to, for this course, yes, you have to solve a lot of practice problems. Some of them we have given the assignments, but you have to solve a lot of practice problems from standard textbook. Okay, thank you. So if there are no further doubts, then we will meet in the next class. Let's try to meet on Monday. Let me inform you.